Okay, students, let us now proceed to diving into lesson 4-2. 4-2 is going to depend on you having learned your features from 4-1, and we are just going to keep it very basic, okay? So here in lesson 4.2, we're going to begin by trying to come up with the equation of our trig function based on the description that's being provided. So right here at the top, you're going to see that we are being given the instructions to find a cosine function that has a midline of 5, an amplitude of 4, and a period of 4 pi over 3. So from section 4.1, we learned that the midline was going to be depicted by the outer value that is added or subtracted to the function. The midline basically tells us what the vertical translation of the trig function is going to be. So in this case, since our midline is 5, we are going to know that our function cosine graph is going to go up 5 units. So again, midline is the equation of the horizontal line that cuts our graph in half, but it also tells us that our graph is going to go up 5 units. Okay? Now, when they gave us the next value, they gave us amplitude of 4. The amplitude of 4 we learned in our first section again was always going to be the coefficient of our trig function. The amplitude of 4 is always a positive value, but just to throw something in here, if they had told us that our graph was reflecting over the x-axis, okay, just for example, I'm giving you this, you would tell us that the amplitude is a 4, but when writing the equation, you would make sure to put a negative in front of that 4 to depict reflection, okay? But anyway, I'm going to erase this because that's not the case for this problem. Our amplitude is 4, so again, right over here, we are stating what we know. Amplitude is 4. So the new thing for us really is the period. They're giving us period of 4 pi 3. Now we learned how to look at a graph and determine what the period is. And here they're giving us the period, and they're wanting us to use that information to help us write the trig function. Okay? Now, right here, this b value, which is always going to be the coefficient of our x, okay, coefficient of our x, that is going to be known as our period, okay? That is used I'm confusing myself, hold on. That is used to help us determine our period, yes. So our B is our frequency, and we are going to use our period to help us find our frequency. That's what I'm trying to say. We don't know what B is. I am so sorry. I got so confused there. Okay, so B is the coefficient of our x. B is known as our frequency. Now, in section 4.1, I'm going to write this over here. In section 4.1, we were introduced with the fact that in order to find our period, all we had to do was take 2 pi and divide it by our b being our frequency, okay? Or if it was in degrees, we were doing 360 degrees divided by our b. Now what's happening is that instead of us looking for period, Now I'm asking you to find frequency. So we have to rewrite our formula whereby we isolate our B value. So what are we going to do? Well, this 2 pi is going to move to the other side. And notice here, this is how our formula looks now. So instead of period equals 2 pi over b, we are going to do b equals 2 over period. Now, all I did was take what was given to me over here in 4 pi over 3, and I am substituting it. Again, drawing another arrow here to help guide my thoughts. Substituting period for 4 pi over 3. Do not forget, when you are dividing fractions, this is a stack fraction. Remember, in middle school, we would write it something like this: 2 pi divided by 4 pi over 3. Okay? You always would, the elementary teachers like to use the little saying, keep, change, flip. As a high school, what I would tell you is you would be multiplying by your reciprocal. So what do I mean by that? Well, you are going to write 2 pi. The division symbol becomes a multiplication. Your 4 pi over 3 becomes 3 over 4 pi. 2 pi times 3 is 6 pi. And 1 times 4 pi is 4 pi. Notice that our pi's are going to cancel, and 6/4 becomes 3/2. And anyway, so that becomes our b value. So notice again, all you guys are doing is finding what A, B, and C are. So A, B, and C, and substituting it with what we found. There's my A, there's my B, and there's my C. So it follows the form A cosine bx plus C. And notice here, they told us it was a cosine function. They will tell us what kind of function it is. Okay? All right, so next, moving on here. Next, what you're going to do is notice there's going to be a slight difference because they are going to give us here a graph, and they're wanting us to use the picture of this graph to come up with the equation of this trig function. And since we know, let me write down the formula here, that the format of our equation has to be y equals a either cosine or sine. So cosine or sine, okay, of bx minus c plus d. My goal is to find the amplitude, the frequency, and the midline equation, or the midline value. Okay, so that's where this is coming into play. So what I always tell students is always start with your midline value. That's the first thing you want to do. Why? Because it's pretty straightforward and easy to see graphically. Okay, so let's do that. So if we had to cut this graph with a horizontal line right down the middle, our maximum value is a 3. Our minimum value is a -5. The halfway point between -3 and -5 is a -4. And I know visually you could see that as well. So I'm going to put this ruler as close as I can get it. You can't get it there. And let us draw that dashed line that shows where our midline is located. Okay, and for practicing purposes, let us go ahead, let's get this thing to disappear, write down the equation of this midline, y equals -4. So please don't forget that you should always write the equation of your midline in equation form, y equals. But here, for purposes of midline, I know that midline is going to be my, hold on. You see this formula right here? I forgot. In section 4.1, we used a C value, but we're ignoring it for this section. So in this section, we're calling it C. So for my midline, my C value is -4. Okay, so the graph went down 4 units basically. Okay. Secondly, what you want to do is find the amplitude, because the amplitude depends on your midline. Depends on midline. Why? Because the amplitude is the distance from the midline to your max value or the midline to your min value. And that unit, or that difference right here, that difference is your amp value, which in this case is a 1. Okay? It's 1 unit up or 1 unit down, but we always take the absolute value. So amp is 1 unit. Period. So the period is the length of one cycle. Okay, so I'm going to erase some of these marks to help us. Well, I don't think we need to. I take it back. We won't erase. So your period is the length of one cycle. So if I start right here, okay, and I'm going to highlight my path that I'm going to take to complete one cycle. So if I can get this highlighter. So I start here at 0, -3. That's where that dot is. 0, -3. I want to be able to end at the same y value. So I start here at -3 and I traveled, and I traveled, and I traveled until I get to -3, and I hit -3 right there. So I'm going to stop right here. Okay. So notice I went from 0, -3, and I traveled all the way to 12 pi, -3. Okay. My period is the length of that period, and length, I mean, is going to be horizontal. That's the length I'm talking about. That is called the period. So if I started at 0 and I ended at 12 pi, I only traveled 12 pi units. So period is going to be 12 pi. And I'm going to use my period now. I'm going to be able to find my frequency, which in this case is my B value. What is my B value formula? It is 2 pi divided by the period, which is 2 pi divided by 12 pi. The pi's cancel, and it reduces to a sixth. So now I can write my equation. Y equals, my A value is a 1, so I can write a 1 or leave it as is. And then it's going to be cosine. Oh my goodness. Cosine, open parentheses, bx, my b is a 1/6, times x plus a c. And not plus a c, plus my c value, which is -4. So let me just write this. Instead of plus -4, I'm going to put -4. You can still write plus -4. It's not wrong. And I am done. Okay, now, if you are asking yourself, wait, how did you know it was a cosine? Why wasn't it a sine value? I'm going to show you that next. Okay, so here we go. Let us shift a little bit more. And what I'm going to have you guys do is follow along with me here. I'm going to pull this ruler up and see if I can pull this up. If it will come up with me. Okay, there we go. I'm going to draw one horizontal line right here. Let's make it. Let's do one horizontal line here. And we're going to draw another horizontal line down here. We're going to have two separate graphs, by the way. And let me change this. And let's make this 90 degrees. So draw this here and this here. Okay. All right. Now, what do we need to do here? So I am going to split this up. I want you to put a little tick mark here. Let's call this 2 pi. And then halfway from there to there, let's call this, that's about pi. And then we'll have a tick mark here and a tick mark here. Half of pi would be pi over 2. And that's pi over 2, 2 pi over 2. This would be 3 pi over 2. And then this is 4 pi over 2, which reduces to 2 pi. Okay. And we're going to do the same thing on this side. Let's make this 2 pi long. Split 2 pi in half. That looked like about half. Probably more around here. Let's call this pi. Half of pi is pi over 2. And then this has to be, that's 1 over 2, 2 over 2. This has to be 3 over 2. And then I want you to put a positive 1 up here and a negative 1 here. And then let's make a positive 1 here and a negative 1 about right here. All right, so this here is going to be our cosine graph. And it just doesn't like my C's. Cosine theta. And this one's going to be sine theta. Okay, where this angle, this x-axis is my theta axis, by the way. All right. And then this right here is the y-axis. All right, so why am I sharing you all with that? Okay, now here is what's going to happen. So I need to get a unit circle here a second. So let me see if I can find a unit circle for us. 1 second. I'm looking for a pause button here. Okay. Bear with me here as we go look for a unit circle because it won't pause for me for some reason. So you can go searching on the internet with me here. I should have had something ready. Okay, let us copy this image and return over here. And this should work. Paste. All right, that was easy enough. Okay, so here's our unit circle. So here's how you know what a sine graph looks like and a cosine graph looks like. So cosine stands for our x values. I want you to notice that in our problem, I specifically wanted us to go through pi over 2, pi, 3 pi over 2, and 2 pi. And I start at 0. So I'm actually having us focus on just 0. Then we went pi over 2. Here's pi over 2. Then it was pi. Then it was 3 pi over 2. And then it was 2 pi. So then we come right back here at 2 pi. Okay? So I'm going to do a different color just to make it a point. Okay? We started off here. And then we ended up here. Okay? So we have 5 points. The 4 yellows, and then the last point was the blue. So we are going to plot these values where cosine, remember, are our x values. So when it was at 0 degrees, our x value was a 1. So our x value was a 1. Then at pi over 2, our x value is a 0. So I'm going to plot it on the 0. At pi, my x value was a negative 1. At 3 pi over 2, my x value was a 0. And at 2 pi, my x value was a 1. So if I connect these dots, let's use green here. I'm going to connect it. I'm going to loop this here like this. Alrighty. So if I connect these, it's going to look like this. Okay, these are not the smoothest graphs, but here are our waves. And they go on forever in both directions. Okay? The sine graph, notice we are going to do y values. So let's do y values. The y value here at 0 degrees is going to be 0. So this time I put it here. The y value up here is a 1. So I go up here at a 1 at pi over 2. My next angle is pi. So at pi, my y value is a 0. Then at 3 pi over 2, my y value is a negative 1. And at back to the starting point, 2 pi, I end up back at 0. So if I connect these, this one's always a little bit easier to draw. This is what my sine graph looks like. It's a little bit off on that one. Let's try that again. Okay. That's sort of okay. Let me try that again. There you go. All right, third time's the charm. That's the best I can do. Okay, so notice how my cosine graph, think of it like a roller coaster of sorts. My cosine graph starts here at the top, and then it just drops down in traveling, and then it goes back up, you know. But the what do you call it? Whoops. The sine graph, it starts here on the ground and it kind of just travels up, 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 and then it drops for a long time and then it goes back up. Notice the different pathways they're taking. So if we go back to this problem here, where you may have been asking, how did you know to choose cosine? Well, I want you to take a look at this graph that we were looking at originally. Okay, if I can get my yellow here. This graph had started here and it went down and then went back up. Which one of these two graphs does that? Well, this one starts going down and then it goes back up. That imitates the cosine graph. That's why I knew it was a cosine graph. Okay. Last but not least, you guys are going to be graphing, and we're going to practice that by going to our Delta Math section. So let's go over there.